How's it going? This is Mr. Morgan. We're gonna look at a few things. We're gonna look at a little stoichiometry, and the first thing that I want you guys to do is take a problem, right? And the problem is this. This is a simple chemical equation, and this is what you're going to be hit with on the stoichiometry, right? In this question, they give you the formula. It's balanced, right? And so with the balanced formula, now you can proceed to the stoichiometry. And the question is, how many moles of oxygen gas are needed to react with 26.4 moles of ammonia? And they give this to you, and I got right down here this step, which is great, but we're also going to use this step, right? And on here, we're going to take 4 moles of ammonia and 5 moles of O2, and it goes to 4 moles of nitrogen monoxide and 6 moles of water. So this is all great. It's a double displacement reaction. And so what we're going to do is we're going to use this to set it up, right? And this I put in, you can get this right on the website, right at your homepage. So we're going to look at this, and we're going to read the question. How many moles of oxygen are needed to react with 26.4 moles of ammonia? The first thing I want you to look at is, what do you have and what are you going to? You are given 26.4 moles of ammonia, right? So on here, you're given 26.4 moles, right? 26.4. That's what's given. Moles of NH3, right? And this is pretty important. All right. And then here's the thing that everybody needs, this mole ratio. The first thing when you're doing stoichiometry is to set up your mole ratio. What is given and what are you looking for? You're given ammonia, right? This is ammonia. And when you're setting up the mole ratio, you need to look at your coefficients of what is given, right? And what are you looking for? Oxygen. How many moles of oxygen are needed to react with 26.4 moles of ammonia, right? So what is given goes on the bottom. What you're looking for goes on top. And that's going to set up your mole ratio. So on here, you're given NH3. And you're in accordance with the mole ratio, you have 4 based on the coefficient, right? And you have 5 right here moles of oxygen in your balanced formula. So now you got a 5-to-4 mole ratio. And the way that we get that is just by looking at the coefficients in front of the molecules, right? And so you got 4 to 5. 4 goes on bottom, 5 goes on top. These cancel out nicely. So your ammonia is gone and you're left with oxygen. So then now, since you're going to moles, it is simply a multiplication. 26.4 times 5 divided by 4. That's it, right? And so when we're looking at this, it's a simple thing. 26.4 times 5 divided by 4. And you can go right into Google Calculator right here. Boom. 26.4 times 5 equals divided by 4. And since we have moles to moles, that's it. That is the entire thing. You have 33. Now, what if it was going to grams? right? What if it was going to grams? Then you just simply, if it was asking like how many grams of oxygen would be needed, right? Then all you do is take 33 moles and multiply it by 32, because O2, right? Oxygen is 16. So you just multiply that little guy by 16 times 2, because you have O2. And that's it. You would need a kilogram of O2. That's it, guys. That's all you do. All right. With that, good luck on this assignment. And if you need anything, let me know.